of exponents. Yay, it sounds so exciting. Okay. What I like to do with these things is I like to build off the number 2. There's a reason that I like to do this, go this way. I'm going to say, let me ask you this. What is 2 to the first power?
1, 2, 2.
Which is it?
2.
2, okay. What's 2 squared?
4.
What's 2 to the third?
8.
2 to the fourth?
16. 32.
And so on and so on and so on. Everybody agree with that? Okay. Let's go the other direction. What's 2 to the 0 power? 1. Very good. 1. One of the properties of exponents stated that anything to the 0 power is always going to be 1. Doesn't matter what it is. It's always going to equal 1. Now what happens when you start going negative? What's 2 to the negative 1?
0.2.
No.
No?
It's 1/2. Very good. It's 1/2.
Just say negative.
Yeah, what's 2 to the negative 2?
1. Negative 1, I mean.
1/4. What's 2 to the negative third? 1/8. Here's what's happening, and this is one of the properties that you guys tend to forget about. One of the properties of exponents states that anything to a negative exponent. When you're negative, you're not happy. Do you agree? A lot of times when you're not happy, if you change the place that you are, you become happy. For example, you guys don't like math. The moment you get out of here, you're happy, right?
I like math.
For the most part. You know.
One of the last classes.
So if you're a negative exponent, you're not happy on the side that you're on. This guy right now, if I say it's x over 1, he's not happy. Where is he going to become happy?
If you add the
Top.
exponent.
Exponents are happy when they're positive, because you're happy when you're positive, right? Most of the time. So if you're a positive exponent, you're a happy person. You're not happy if you're negative. So if you're negative in the top, you're positive when you're in the denominator. But what happens if you're negative in the denominator? You're positive on the top. And that's one of the rules of exponents that you guys tend to forget. Remember, it wants to jump the border. Okay. Negative exponents are happy when they're positive. So if they're negative in the numerator, they're positive in the denominator. If they're negative in the denominator, they're positive in the numerator. Vice versa, versi, vice. Get that up. Okay. Now let's look at the other rules. Dun dun dun. I honestly don't care what these things are called. I just want to show you. Whoa. Sorry about that being that loud. You already know these. It's not so much that you don't need that you have to memorize them. You already knew these. And I'm going to go one at a time with them and kind of give you an example as we go through. Here's what's happening. If we're looking at bases and exponents, base is the A, exponent is the M. Base is the A, exponent is the N. So if I have two things being multiplied together that have the same base but different exponents, all I do is take that base and I add the exponents. For example, if it's x cubed times x to the fourth, what do you get? X to the 7. You've done that before. And the reason that that works is because when you're multiplying things together, bless you, if I'm looking at x to the third, isn't that just x times x times x?
Yeah.
Okay. So x to the third is x times x times x. X to the fourth is x times x times x times x, which is how many x's?
7.
That's why that works. Okay? Not so scary? Like I said, you don't need to memorize it, it's just a refresher. Okay. Power to power. When you have power to power, you multiply them. It's raising an exponent to an exponent. So in this example, I would say, bless you, if it's r to the 4th to the 5th power. That's basically saying you've got r to the 4th 5 times, which is r, 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 r. That's very funny. R Reba Dirty.
Okay. Yeah.
What's that? Oh, that was awesome. That was great. Running out the door like that? That was sweet. Bless you. I scared the bejesus out of you guys. That was so much fun. It was terrifying, wasn't it?
I remember what really happened. I didn't know what was going on.
Next you know, you see me running out. I gotta learn how to do a backflip. That's pretty sweet.
Like everybody was like yelling and like just like jump, and then I saw you run back inside.
Think of this one as the distributive property of exponents. If you have two different things raised to an exponent, when they're being multiplied, each one of those terms inside the parentheses needs to be raised to that exponent. Okay. So if you have xy to the 3rd power, remember that means xy times xy times xy, which is x cubed y. Okay. Think of it as distributive property. It's the same stuff as chem from your elements.
Okay. They're on the significant.
Yeah. Figures.
I hate significance. 5 times 5 equals 30. Terrible.
We never have to worry about them.
It's true.
I don't like them either. I honestly can't remember. People always ask me once in a while, how do you say figs? I'm like,
Just tell them 5 times 5 equals 30.
Here's what we were just talking about. This is the one that you guys usually screw up.
Yeah.
It's the negatives. Remember, when you have exponents that are negative, that means they're not happy where they are. So you need to change their seat, change their spot, move them. So if they were unhappy in the numerator, they become happy in the denominator. And just like I said earlier, if they're unhappy in the denominator, they're happy in the numerator. Okay? That's the one that most people mess up. Anything to the 0 power is always what? 1. Anything, anything, anything. Doesn't matter what it is. It's to the 0 power, it's 1. What? Hope those voices calm down a bit. Nothing. This is the one that I call the game of war. I don't necessarily always go by the m minus n for when you're dividing out your exponents. What I like to do is the following. I'm going to put this on a separate sheet real quick and walk you through how I set this up. So what I'm looking at here is the following example. If I have x to the 12th power over x to the 3rd power, who wins the battle of war? A 12 or a 3?
12.
What's 12 minus 3?
9.
9. The reason why I'm asking who wins the battle of war here is because that way you know where the x value is going to stay. It's going to stay in the numerator, it's going to go to the denominator. This becomes x to the 9th. If this was x to the 12th over x to the 30th, now who wins the battle of war? The 30 does. So since that wins the battle of war, it would be 1 over x to the 18. Not negative 18, it'd just be 18.
Because if it's on the top, it will be negative.
Okay? What I'm doing here is, if you work it through with this nomenclature, you would have written it as x to the 12 minus 30, and then you would have gotten x to the negative 18th, which means you would still have to rewrite it as x to the 18th. Oops. 1 over x to the 18th. By just going by the game of war, it's one less step, and I think it's a little bit cleaner. That's all. Does that make sense?
Yeah.
I know that you guys have also, like I said, you've seen that, but that's usually, it's just one little trick that I write it out that way. Okay. Okay. It's crazy. And then, lastly, it also works for the distributive property of a fraction. Oops, sorry. Kind of your way here. If you have it written out as a fraction raised to a power, you distribute that exponent to both the numerator and as well as the denominator. Let me move this up so you can see it. So if I had something like x over y cubed, you distribute that cubed term to both the x and the y. Okay? Like I said, a lot of this is straight review. Should not be that difficult. Oh, but it usually is. Sometimes, yes. All right? So, where was it here? Let's do... Was fun, wasn't it? Take a couple minutes. Try those.
All of them?
Sure.
I'm just gonna go.
No, let's just start on 13 then. Let's start at 13.
I'll go with 13 odds.
No, it's not going to kill you. Take a couple minutes to get those. We'll check our answers. All right, let's hopefully see if you got these right. One thing I would like you guys to do is anytime you get one of these and you have a numerical value that you can come up with, please simplify it. So don't just write it as 2 to the 3rd, just write 8. Okay. Next one, you get 4 to the 4th, x to the 12th, so the, was it 16, 256?
Yeah.
256, x to the 12th? 15, I'm looking at 1 over y squared.
Oh, yeah.
Okay. Now, one thing that I didn't really discuss with you guys when it gets into these types where you have numbers and variables, always just look at your numbers first. Well, 5 and 2, I can't do anything, so I'm just going to leave it. And then when I have these multiple values, I'm just going to start rewriting stuff. I have x squared is fine, y is fine. I got an x to bring up and a y that stays down. You okay with that? I'm just taking a quick second by rewriting things to have positive exponents. And then I'm going to start doing my combinations. When I'm done with this, I get 5. This becomes x cubed. And then I have a y over y cubed, which is y squared where? The bottom. Yeah. Okay. Now, in the next one, it's -3. So we see half here is just negative. Yes, ma'am. Oh, I just forgot to write it.
Yeah,
Nothing.
all right.
I just forgot. Now, is that 3 happy or is he just negative for being a negative value? Does he move? No, he doesn't move, okay? That -3 doesn't move, it's just because it's not having anything to do with his exponent. So in this case, you can simplify though the -3 over 9. What do you get? -1/3. So I'll write -1 over 3. X over x cubed, what do you get? X squared on the bottom. Now you have y over y to the -4. What happens? Y5 where? All right.
Is it okay if I put negative Wi-Fi?
Yes. Yep, that's fine. It's the same thing. And then lastly, you have parentheses 3x squared. What does that become? Yes, ma'am.
How did you get to that?
I have y. Here we have y over y to the -4. That -4th power is not happy, is it?
Yeah.
So it's got to move up. So you get y times y to the 4th. That's where it gets fulfilled. Should be what? No, because you're adding your exponents. Because this is a 1.
Okay.
That's wrong. What? No.
Alright.
3x quantity squared is 9x squared over 6x to the 5th. Hopefully you get, what was that, 3 halves. 3 over 2x cubed.
I got that.
You're all right? What happened? All right, I'll go. Oh, let's see. I'm not sure how far you guys are, if a lot of you guys are already at number 6 here. Well, about half of you guys have already answered this question. I want to walk through what happens with all these negative exponents. I'll tell you this time and time again. The negative exponents is what's going to get you, okay? When you get to a problem that you have multiple properties that you have to work with your exponent rules, in this case, we have to distribute that negative 2 exponent to each individual piece within the problem. So there are 4 parts to that parenthesis, 2 in the numerator and 2 in the denominator. Each one of those has to be distributed to a negative 2. Using your exponent rules and your power to power, x to the 3rd raised to the negative 2 becomes x to the negative 6. Do you agree? Okay. So here I would get x to the negative 6, y to the negative 4, over 2 to the negative 2, x to the negative 4. Everybody okay with that? Everything has been raised to the negative 2 power.
No, that's negative.
Oh, sorry. Thank you.
Question,
Yes, ma'am.
would that, never mind, I'm just gonna wait for you to go.
Okay. At this point, work with your negatives. Is that x to the negative 6 happy in the numerator? Where is he happy? Is that y to the negative 4th happy? No. So he's happy. Is 2 to the negative 2 happy in the denominator? Where is he happy? And then it's x to the 8th. Did you flip everything right at the beginning?
No, you see, I worked out like the 2
But then you gotta
negative 2, so that 0.25.
That's wrong though, because 2 to the negative 2 isn't 0.25. Now you simplify out, you get 4x squared over y to the 4th. Okay. Ladies and gentlemen, don't try and do all of it at once. It's just going to get nasty. Remember, it's not 2 to the negative 2 here. It's 1/2 to the negative 2. You think about what this really is. There's a 1 here. The number is 1/2. Yes, ma'am. Continue on here. We'll check in a minute or so. We'll run out of time.